So in 8.1, we talked about complex numbers. And in this section, we're going to talk about rectangular and polar forms of complex numbers. A rectangular form is kind of the form you're used to seeing a complex number in, something like maybe 2 minus 3i. Okay, this is kind of in your book on around page 359. Okay, so you have this problem, but we're going to show you that we can actually graph this by kind of changing our axis a little bit. We know this is the axis, x-axis. This is your y-axis. But we could also call this x-axis, let's refer to it as the real numbers. And the y-axis we're referred to as imaginary numbers, kind of I, okay, imaginary. And then what we could do on this thing is we could just graph this. This number 2 is the real number, so we go 2 units. And then the imaginary number is a -3. So if we went to -3, we'd end up at a point somewhere over here. And this would be our point to -3. We could draw kind of a, what would you call that? Call that a vector to this point, huh? And what would this vector represent? Well, this would represent, maybe if there was a circle going through this would represent the radius, huh, of a circle. We call it r. Or basically, it's the hypotenuse of a right triangle. If we extended this back up this way, we could think of this as a right triangle. This would be our angle and so on. So we could kind of convert this over. So you can kind of see that maybe we could change this rectangular form to what we call a trigonometric form, where we have something with an angle and a radius, and we call that sometimes trig form, or sometimes we call that polar form. So we could write a complex number that we usually see in it this way into something called polar form or polar coordinates, you know. So that's what we're gonna kind of look at in this section. We're used to kind of seeing things in this form, but we're going to change them a little bit around. So this would be in the x direction, right? And this would be the y direction, x and y. So looking at this angle right here, and we wanted to use a reference, let's say with using x and r, what relationship would that be? Well, if r was our hypotenuse and x was our adjacent side, that would be cosine, huh? So cosine theta equals equals x over r, huh? But if we wanted to rewrite that, say we wanted to find out what x was instead of cosine theta, could I rewrite this? Could I, it's a proportion. Could I just multiply those and say x equals, and I'm going to times these together, r times cosine theta. R cosine theta. And what about y? Well, a relationship with the y would be, this is the opposite, and this is the hypotenuse. So sine theta equals y over r. So y would equal r sine theta. Okay, so we could rewrite them a little bit that way. What about r? How could we find r if we wanted to find r? Well, if this is the longest side, r squared would equal x squared plus y squared, or r is the square root of x squared plus y squared. So these are kind of important relationships, x, y, r. And if I want to find this angle and I knew x and y, I could say, what would that be? That would be the tangent, huh? The tangent of theta is equal to the opposite, y over x. So on page 360 at the bottom, they give these relationships, but this is how they're developed. So let's write these down on a separate sheet of paper here. Just recopy them, okay? Let me slide this over. Okay, so one important relationship is, what is x? X is r cosine theta. Just because, I just took this relationship that we've always been using, the opposite over the hypotenuse, or in this case, the adjacent over the hypotenuse, and just kind of rewrote it for x. I just simply multiply both, cross multiplied this. So, and the same thing with y equals r sine theta. And then finally, r itself could be, because it's the hypotenuse, it's x squared plus y squared, and then we take the square root of, that would be r squared, so we take the square root to get r. And finally, we know that the tangent of theta is equal to the opposite over the adjacent, y over x. Okay, so we have these important relationships. Okay, so let's take a look at a problem written in the way we normally write this one. Let's say we had 2 minus 3i, or we could have 2 plus 3i. So we could have x plus yi. But what is x? X is r cosine theta. Plus, what is y? Y is r sine theta. But we also have this I, so it's, I don't know where we want to put it. Let's put it in front. Okay. So that would be our polar form of a problem. But notice both of these have an r, so we can just kind of factor that out. So cosine theta plus I sine theta. So this is another way of writing something like this, 2 plus 3i. We could write it in this kind of thing. And sometimes we abbreviate this a little bit. We call this R CIS, cosine, imaginary number, sine. So we abbreviate this. Instead of writing cosine theta plus I sine theta, we just write it as CIS, cis. And so it'd be RCIS. So this is what we call the polar form or the trig form of a complex number. So a complex number could be written this way, or it could be written this way. This is what we call algebraic form or standard form, and this is what we would call polar form of the same number. So what you're concerned in this chapter is, how do you switch from one to the other? Okay, so that's what we want to try to do. We want to try to figure out how we can change from one to another. So let's say, we are in polar form and we want to translate to trig form. Okay, so we want to convert from trigonometric form to rectangular form. Trig to rectangular. So let's take a look at one. The problem might be written this way. It's in trig form. It's written 2 CIS 300. Okay, so this is trigonometric form of a complex number. And we want to say, okay, yeah, well, that's wonderful, but what does that mean in it doesn't look anything like this, so we want to try to get it to look something like that in a regular form. So the first thing we're going to do is expand this out. This is 2 times the cosine, times the whole thing, cosine 300 degrees plus I sine 300 degrees. See, this is just a simplification of, that's really what they're saying here. CIS 300 means the cosine is 300 and the sine is 300 and there's an I in front. Okay, so that's the first thing we do. Then on using our little chart, let me see if I can find my chart. There we go, lucky. We look up the cosine of 300. So the cosine of 300 is 1/2. So 2 times 1/2 plus I, and then we look at the sine of 300. The sine of 300, let's see if we can find the sine of 300 right down here. The sine of 300, negative radical 3 over 2. Negative radical 3 over 2. Okay, so then we put those in and we just simply simplify it. Okay, so we're going to distribute the 2. 2 times 1/2 is 1 plus I, and 2 times radical 3 over 2. The 2's will cancel, be 2 radical 3 over 2. So that'd be negative, let's put a negative radical 3. So we could simplify that to 1 minus I radical 3. And now it's in polar form, see? I mean, rectangular form. It was in polar form. Now it's in rectangular form. So it's very easy to convert over, you know. So let's try another one. Suppose you had this one, 10 CIS 135. Okay, so we want to convert that over so that makes a little bit more sense. It's 10 times the cosine of 135. It's just in different notation that we're not used to as much, plus I sine 135 degrees. So once again, we're going to look up the 10 times the cosine of 135. So we use our little chart here, find 135 right across. Okay, the cosine is going to be negative radical 2 over 2, and the sine is going to be positive radical 2 over 2. So this is going to be radical 2 over 2, negative, and the sine is going to be I radical 2 over 2. Okay, so we're multiplying this by 10. So 2 goes into 10 5 times. This will be a negative 5 radical 2. And 2 goes into 10 5 times. So this would be, to get rid of our denominators, I 5 radical 2. I usually don't write it like that. It kind of looks a little weird. So we probably write it as negative 5 radical 2 plus 5I radical 2. It looks a little bit more pleasing to the eye. And that's our answer. So we've translated from polar form to rectangular. Very easy to do, huh? Polar, rectangular, or algebraic. So we can convert it over. Pretty good to say. Well, we haven't used any of these little formulas, have we? Remember, we wrote down these formulas, but we're not really using them here. We're just kind of converting over. So I was just kind of showing you that it could be written that way. But we're going to use them in just a second. So now we're in polar, and we can convert over to rectangular. Very easy to do. You know, just if it's written 2 CIS 300, expand that out so it makes sense. Look up the cosine, look up the sine, and just kind of simplify it a little bit. All right, so now let's see what happens if we're in rectangular form and we want to, so this was polar to rectangular. Let's say we want to go rectangular to polar. Rectangular to polar. So this might be a little bit more difficult to do, huh? Okay, we'll see what we can do. So there's some instructions in the book. It says first, sketch the graph of this rectangular coordinates, then find R by using kind of Pythagorean theorem, and then find the angle tangent theta by using the tangent. Okay, so let's see what they're talking about. All right, so now we're in rectangular and we have this negative radical 3 plus I. Let's call it 1I just to make it easier. Okay, so it says first, try to graph this thing. Okay, let's draw. You don't have to draw it, a huge graph. But remember, this is your real numbers. This is your imaginary numbers. This is kind of like your x's. This is kind of like your y's. Okay, so this is like x, and this would be like y. Okay, so x is negative radical 3. How do you show negative radical 3? Well, I guess we got to go in the negative direction. If you look up radical 3 on your calculator, it's about 1.732. So it's going to be a little less than 2. It's going to be somewhere around in here. And then we're going to go up 1 unit. So it's going to end up right about there. Okay, this would be negative radical 3 plus 1i. The reason we sketch this is because we want to kind of look at this angle right here. Of course, we're projecting this down. So we have an angle inside here, we're calling alpha, but this is the main one we're looking at, this angle right here. So let's see, what else can we do? This is kind of a small graph. I should have made it a little bit bigger. Let's just make this a little bit bigger so we can kind of see it. Okay, so we got this point up here, and this point was negative radical 3, comma, or plus, we could just write plus 1i. Okay, so this distance right here was negative radical 3. This distance here was 1. Projected this down. This right here is alpha, theta. This is alpha inside there. Okay, so let's see what else we can do to this. So it said first we want to draw this. Then it said, what's the next thing? We want to find out what this distance is right here, r. So r equals the square root of x squared. Well, x squared would be this distance, this distance right here, negative radical 3 squared plus, and y would be our 1 distance. This is really, this is your real part, and this is your imaginary part, but this distance right here is x, and this is pretty much y, huh? So 1 squared. So let's see what that is. A negative radical 3 squared would be a positive radical 9, which is 3, plus 1 squared is going to be 1. So it's the square root of 3 plus 1, which is the square root of 4, which is 2. So now we know what r is, huh? All right. The next thing we want to do is we want to use our tangent to find this angle right here. Tangent theta is equal to y over x. Okay, what's our y distance? 1 over our x distance, negative radical 3. Right? So what is that? We're going to rationalize that. And we can put the negative on top. So we're going to multiply this by radical 3 and radical 3. So that looks like it's negative radical 3 over 3. So let's look at our chart here. We want to actually find the angle. Theta equals inverse tan of negative radical 3 over 3, the arctan. Okay, so here we have negative radical 3 over 3. Where is negative radical 3 over 3? We got one down here, we got one here. Well, according to our drawing, it looks like our angle is in the second quadrant. So that's the one we want because we have 2 of them here. But we want ours in the second, so negative radical 3 over 3. We could either write this in terms of radians, or we could write it in degrees. Let's go with this one in terms of degrees. And in fact, it said, well, it asks for radian measure. Okay, the instructions on this premise said radian measures. Okay, well, that's okay. This is 5 pi radical 6. So theta is 5 pi radical 6. So how would we write this? Well, we've done everything we need to do. This is it's going to be 2 CIS 5 pi over 6. We found our radius and we found our angle. And that's the problem written in polar form. If you want to expand it out, you could say this is 2 cosine 5 pi over 6 plus I, 2 times the whole thing, I sine 5 pi over 6. So what do we have to do? We did a drawing, kind of a crummy one there. So we did a drawing, and then from that drawing, we were able to figure out what R is, x squared plus y squared. Figured out, this gave us our radius. The radius is in front of here. This is R, right here, R. And then CIS, cosine, plus I radical, I sine. So we figured out our angle by using our tangent function. So you don't really have to use cosine and sine in here. You're just going to use your tangent function. And you convert it rectangular to polar. Let's try another one here. This is kind of a weird one. They said convert this. They said use the degrees. Convert this over to, this is, right now it's in rectangular form. And we want to go to polar. So we're in rectangular, we want to get to polar, but it's not quite rectangular. Let's put a real number. We got the imaginary, so we need 0. Okay, so this is kind of weird. So in the x direction, we're not going to go anywhere. We're just sitting there. In the y direction, this is your real number. This is your imaginary. This is x. This is y. So in the y direction, you can think of this as the y direction or the I direction. We're going down 3 units, 1, 2, 3. So we're going to end up right at this point right here, 0, 3i. Okay. So this is telling me I can almost look right here at the drawing and tell what theta is going to be. What's the angle? 270 degrees. I mean, I don't even have to really do much on this one, but I do have to figure out what the radius is. Well, I don't even have to do much on that because I can look down here and see my radius right here is 3 units. So this was a kind of a silly little problem because now I know this is going to be 3 CIS 270 without actually really doing anything. It's going to be 3 cosine 270 plus I sine 270. So I really didn't have to do much at all. I didn't have to reuse the what do you call it? Pythagorean theorem and all that kind of stuff. I could just look at the graph and tell the radius is 3 and the angle is 270, So I didn't really have to go crazy on that one. So let me give you one that's a little bit better to work with. That one was kind of silly. Okay, let's try this one and let's put this one in. Let's calculate this one in degrees. 8 minus 8i. Okay, let's see what the sketch would be. 8. Well, in this case, we're going in a positive direction. Okay, 8 units, and we're going down 8 units. So we're down here someplace. 8 minus 8i. This right here is going to be our radius. This distance up here is, we could write it as a negative 8 or a negative 8i. This is our imaginary, and this is our real. Or this is x, this is y, and this distance right here is x. Okay, so we got that much done. The next thing we want to do is we want to figure out our radius. The radius is simply the square root of when we put this in, we're not going to put in the I necessarily. We're just going to put in the x coordinate, 8 squared. And if we want to put in a negative 8, it wouldn't matter because this would be 8 squared. So the radius is the 64 plus 64. Radius is the square root of 128, isn't it? Well, if we broke that down, that would be 64, 2 times 64. So that would be 8 radical 2. So there's our radius. Okay. A little rusty on this kind of stuff myself. Okay, so we got the radius figured out. That's 8 radical 2. Now we want to find out the angle, huh? Tangent theta equals y over x. Y is we know this is going to be a negative 8 and 8. So that is a negative 1. So when does the tangent equal a negative 1? But we know it's going to have to be, we can see tangent equals negative 1 at 135 degrees. Wait, that's cotangent. Yeah, tangent, the same thing, huh? It's going to be at a negative 135 degrees. But that would be if it's in the second quadrant. This is in the fourth quadrant. So let's go down here a little further. In the fourth quadrant, it's going to be 315 degrees. So now we know that the tangent theta equals the arctan of negative 1. Theta is 135 degrees. So now we have our thing. We have r. So we're putting it into this form, r cis theta. See, that's the form we're putting it in. So it's r 8 radical 2, parentheses cis 135 degrees. Then if we want to, let's go ahead and expand it out. So it looks like we're real pros here. 8 square root of 2 cosine 135 plus I sine. The book doesn't quite do it this way, but I find it a little bit easier to put it in the cis form first, then expand it out, because it just, you're only dealing with two things, radius and degree. So number one, figure out your radius. I guess you could get by without drawing a grid here if you just figured that this number right here is x and this number right here without the I is y. And if you wanted to do it that way, you could, It's in the form x minus yi. So, on this particular one, so we know that y is a negative. See, even if we put a negative in there, it would have come out a positive 64 anyhow. So I suppose it could be done without even sketching the graph. I'm used to sketching the graph, but if you didn't sketch the graph, you'd be okay. Here's your x, here's your y. All you got to do is find r and use your tangent function to find theta. and you can translate back into polar form. So this is polar, and this is what we would call standard or rectangular form. Rectangular, polar, polar, rectangular. Okay, hope this is helpful. That's the main thing you want to be able to do is convert from one to the other and have a little fun with it. And sometimes, these don't always come out exact, so sometimes you're going to come out with decimal equivalents. That's fine too. Maybe this was a real nice angle. This comes out tangent of -1. Maybe it comes out when you're trying to find the angle, it might come out kind of a weird angle or something like that. So then you're going to have to use your calculator to kind of figure it out. They don't always. Let's try one of those just for the heck of it. Let's try this one, 5, -4. And we'll do it kind of the fast way. Okay, so our, here's your rectangular form, and we want to put it into polar, to polar. I'm thinking of the Polar Express. This is pretty good to do around Christmas time, huh? Okay, so I'm thinking, okay, what is x? X is 5. What is y? Y is -4. R is equal to the square root of x squared. I just write it up here. Plus y squared. R equals x squared plus y squared. So R looks like it's going to be the square root of 25 plus 16. R is the square root of 41. That's what I come up with. Okay, next thing I want to find theta. Tangent theta equals y. We know is -4 over 5. So theta equals negative second tan, arctan, -4 over 5. So if I look at my chart, I don't have anything like that. So I'm going to have to go to the calculator if I can find one here. Here's one. Calculator. Clear. So I'm going to hit second tan. There we go. Second tan. And -4 over 5. I could put -0.8, or I'll just put -4 divided by 5 equals. So they gave it to me as a negative angle, -38.7. Theta equals -38.7. I usually want these as a positive number. So what I'm going to do is I'm going to add 360 to this so I can get a positive angle, 321.3. And I think they actually wrote 3.4. Okay. So now I can just put it in polar form. It's going to be R CIS theta. So it's going to be R square root of 41 CIS 321.4. See? 0.34. 321.34. Well, let's expand that out. Square root of 41 cosine, put a parentheses there, 321.34 plus I sine, you look like a genius, 321.34. And there you got it. You just translated it to polar form. So we didn't actually have to do the drawing as long as we identified X and Y. And then at the end, you just put in your I into it. You're not using it really in your calculation here. And now it's a polar form. Same thing. All right. And you can mess around doing the other way. You could have it in polar CIS form and translate it back to the other one. You know, you just look up the cosine of this and the sine of this, and you can translate it pretty easily. All right. So give it a shot, see what you can do.